Tides might seem like a distant natural rhythm, something reserved for coastal beaches or fishermen's almanacs, but they are surprisingly present in daily life, even in places shaped by concrete, glass, and steel. In coastal cities, tides become a regular participant in urban planning, architecture, and even fashion. Rubber boots are not just accessories, they're survival tools. In places like Venice, tidal awareness is baked into every part of life, from transportation to tourism. Meanwhile, in the low-lying atolls of the Maldives, where land rises just a few meters above sea level, tides carry existential weight. A modest rise in water from a spring tide, especially when combined with wind or storm activity, can mean the difference between dry land and encroaching seawater. Here, the residents monitor the moon not out of romantic fascination, but as a vital necessity. Their homes, roads, agriculture, and freshwater supply are deeply tied to the ocean's moods. Every tide is a signal, a warning, and a hope. This close relationship with the tides is not just practical, it's deeply scientific. Oceanographers and climate researchers rely on tidal behavior to understand much larger systems at work. Tides act like giant tracer lines, revealing how energy moves through oceans. By studying them, scientists model global currents, track storm surges, and even monitor how climate change alters water movement patterns around the globe. Tides aren't just happening today, they've been happening for billions of years. And they've been leaving records behind. Layers of sediment, fossilized shoreless, and ancient salt flats all whisper stories of tides long past. By studying these clues, scientists can estimate what sea levels were thousands or even millions of years ago. They can infer past tectonic shifts, track the tilt and wobble of Earth's orbit, and piece together how coastlines have evolved over geological time. In all their complexity, tides serve as a beautiful metaphor. The same forces, the moon's pull, the sun's influence, Earth's rotation, act on the entire planet, and yet their expression is endlessly unique. It's as if one universal melody is being played through thousands of local instruments, each with its own tone, pitch, and rhythm. In one place, a tide may arrive like a whisper, barely disturbing the stillness. In another, it may rush in with thunderous might, churning sediment, stirring wildlife, and altering the landscape in minutes. The song of the sea, shaped by familiar celestial forces, never repeats itself exactly. It's written anew every day by the coastline it meets. And that diversity of experience is important, not just to appreciate, but to understand. If we want to predict how rising sea levels will impact different regions, or how a major storm might compound with a high tide to flood a city, we need to listen closely to the local tide's voice. We need to know how it behaves, what influences it, and how it has changed over time. From a scientific standpoint, tides are like a planetary pulse, a rhythmic, repeating signal that helps us measure Earth's health. They are tied to ocean temperatures, ice melt, wind patterns, and even large-scale oscillations like El Niño and La Niña. By monitoring tides globally, researchers can detect subtle shifts in the climate system, clues that something larger is stirring beneath the waves. But perhaps the most profound thing tides teach us is that no matter how advanced our technology becomes, we are still deeply, unavoidably connected to the rhythms of nature. Skyscrapers and satellites don't remove us from the moon's influence. Apps and algorithms may forecast the tide, but they don't change its schedule. The ocean listens only to gravity, time, and the celestial clock. We are participants in a planetary story written in salt and moonlight. Whether you live on a remote island, a coastal city, or a high-rise apartment far from the sea, the tide's message still reaches you, quietly, insistently, and eternally.